In this video, we are going to a deep dive into how Operator Lifecycle Manager helps to install and upgrade operators. We will cover everything from the basics of Operator Lifecycle Manager to more advanced features such as operator groups and policies. Operator Lifecycle Manager is a Kubernetes feature that provides a way to package, distribute, and manage operators. Kubernetes operators are application-specific controllers that automate the deployment, configuration, and management of complex applications on Kubernetes. OLM is a framework for managing operators in a centralized and declarative way. OLM provides a number of features to help users install, update, and manage operators in their Kubernetes clusters, including a catalog of operators that users can browse and install, a declarative way to install and manage operators using Kubernetes cluster resource definitions, and automated update of operators. Operator Lifecycle Manager consists of three main components that work in harmony: Operator Hub, Catalog Source, and Subscription. Operator Hub acts as your marketplace, showcasing a curated selection of operators. Catalog Source is like your library of operators. It contains information about available operators, their versions, and instructions to install them. Subscription is a way of saying, I want this operator. It defines which operator should be installed in your cluster and keeps them up to date. OLM works by using a packaging format called Cluster Service Version or CSV. Cluster Service Version represents an operator and is a Kubernetes custom resource definition that contains all the information that OLM needs to install and manage an operator, including the operator's dependencies, its installation instructions, and its update strategy. OLM comes with two operators, Catalog Operator and an OLM Operator. Catalog Operator is responsible for managing and maintaining a catalog of operators that are available for installation within a Kubernetes cluster. The catalog typically includes information about operators such as their versions, metadata, and installation procedures. OLM Operator is responsible to ensure that operators are correctly installed, upgraded, and managed according to the desired state. When a user wants to install a specific operator into their Kubernetes cluster, they create a subscription object containing the desired operator to be installed, catalog source, and the target namespace in which it should be deployed. The catalog operator, which maintains the catalog of operators, checks whether the specified operator is available in the catalog. Every catalog source exposes the registry service that allows catalog operator to query operator metadata. The catalog operator validates the metadata in the subscription, ensuring that the operator version, name, and other details match what's available in the catalog. If the subscription is valid and the operator is available, an install plan is created based on the subscription. Install plan contains operator name, version, and list of resources that OLM will create or update. This information can be used by cluster administrators to review and approve the install plan before it is executed. Once approved, a CSV resource is created which is monitored by OLM operator. OLM operator is responsible to ensure that operators are correctly installed, upgraded, and managed according to the desired state. The OLM operator first validates the CSV object, and if the CSV specifies dependencies on other operators, the OLM operator checks if those dependent operators are already installed. If not, it will initiate their installation first. The OLM operator interprets the information in the CSV manifest and proceeds to install the specified operator. It deploys operator-related resources such as pods, services, and custom resource definitions to the target namespace. After installation, the catalog operator continues to monitor the operator status and availability. If updates or new versions become available in the catalog, it will create an install plan and upgrade the target operators. For subscriptions that are configured with manual approval plan, The install plan will be created and wait for a manual approval to start the upgrade process. Now let's get practical. Here is a step-by-step guide to installing an operator using OLM. We are going to use an OpenShift cluster where OLM runs by default. First, open your Kubernetes cluster's operator hub. This is where you will find a curated selection of operators ready for installation. Browse to the available operators and select the one that suits your application requirements. Once you have made your choice, click on Install. OLM takes care of the rest. It retrieves the operator from the catalog, deploys it onto your cluster, and sets up necessary configurations. To install an operator in an automated way, you first need to create a YAML file which contains the operator and its version that you want to install. Then deploy it using the kubectl apply command. To create using Kubernetes CLI, you would run the kubectl create command. Once you have created a subscription, OLM will automatically resolve and install the operator dependencies. Once the dependencies are installed, OLM will install the operator itself. After the operator is installed, it is displayed under Installed Operators. Selecting it will display the details of the operator, including cluster service version and subscription. As part of install, OLM created the subscription which contains the name of the operator, source, version, channel, and namespace where it should be installed. This is the install plan that was created to complete installation of operator. It contains the install instructions like CSVs and CRDs to be created. Operator was installed under OpenShift operators namespace. So the controller deployment gets created under same namespace. This pod presents the controller for Postgres installation. Operator Lifecycle Manager operators like catalog and OLM operator are present under OpenShift Operator Lifecycle Manager namespace. Under OpenShift Marketplace, you will find the catalog sources. So, why it is so significant to keep the operators up to date? Imagine a security vulnerability surfaces in one of your operator's dependencies, or a critical bug causes instability in your application. Outdated operators can lead to security risk, performance issues, and headaches for your DevOps team. OLM automates the entire process of monitoring and upgrading operators, taking the stress out of your equation. It keeps a watchful eye on operator catalogs, looking for new versions, updates, and improvements. To upgrade an operator with OLM, you simply change the channel of your subscription to a newer version of the operator. OLM will then automatically upgrade the operator to the newer version. To upgrade operator as part of automation, update the channel or the version in your YAML file and deploy it using the kubectl apply command. Using Kubernetes CLI, you can run the following command. One of the standout features of OLM is the support for custom catalogs. Imagine you have a specific set of operators tailored to your organization's unique needs. OLM allows you to create custom catalogs, curate your own collection of operators, and define policies for their usage. This means you have full control over the operators available to your teams, ensuring that only the trusted and approved ones are within the reach. In addition to the basic features described above, OLM also provides a number of advanced features such as operator groups. Operator groups allows you to group together related operators. This can be helpful for managing the lifecycle of multiple operators at once. Policies. Policies allows you to control how OLM install and upgrade operators. For example, you can use policies to specify which versions of operators are allowed to be installed in your cluster. There are a number of benefits to using OLM to install and upgrade operators, including reduced manual intervention. With OLM, the installation and upgrade process for operators can be automated, reducing the need for manual intervention and saving time and effort. Simplicity. OLM makes it easy to install and upgrade operators without having to worry about the dependencies and manually managing the upgrade process. Enhance cluster stability. OLM ensures cluster stability by preventing conflicting operators from being installed and managing dependencies between operators and the platform. Safety. OLM ensures that operators are installed and upgraded in a safe and reliable way. Flexibility. OLM provides a number of features such as channels, operator groups that gives you flexibility in how you manage your operators. In the real world, OLM is used by a number of organizations to install and manage operators. Google Cloud Platform uses OLM to manage its Kubernetes engine operators. Red Hat OpenShift uses OLM to manage its operators. Red Hat has integrated OLM into its OpenShift container platform to simplify the management of Kubernetes native applications. OLM has enabled Red Hat to provide a declarative way to install, manage, and upgrade operators, improving scalability and enhancing cluster stability. Amazon Web Services use OLM to manage its elastic Kubernetes service operators. OLM has a number of benefits over other applications packaging solutions like Helm and Kustomize. OLM can automate the installation, upgrading, and removal of operators based on defined policies. This can help to ensure that operators are always up to date and that deployments are consistent. OLM can automatically install and manage the dependencies of operators. This simplifies the deployment process and helps to ensure that operators are always running with the correct dependencies. OLM provides a number of security features such as role-based access control and namespace isolation to help protect operators from unauthorized access and accidental or malicious clients. OLM provides a catalog of operators that can easily installed and managed. This makes it easier to find and deploy operators for a variety of applications. OLM is tightly integrated with Kubernetes, which makes it easy to use and manage. Here are some of the best practices for using OLM. Use a catalog source to discover and install operators. This will help you to ensure that you are installing operators from trusted sources. Use channels to manage the lifecycle of operators. Channels allows you to easily upgrade operators to newer versions without disrupting your production environment. Use operator groups to group together related operators. This can be useful for managing the lifecycle of multiple operators at once. Use policies to control how OLM installs and upgrade operators. This can help you to ensure that your cluster is secure and that operators are always up to date. Thank you for watching our journey through Operator Lifecycle Manager, your go-to tool for Kubernetes operator management. If you find this video helpful and informative, don't forget to give a thumbs up, subscribe to my channel, and hit the notification bell to stay updated with the latest tech insights. Feel free to share your thoughts, questions, or topics you would like to see in future videos in the comments below.